none of the programming languages that are most commonly used were designed for parallel programming. So that brings up the concept of parallel programming models. How can we add parallelism to these languages? And in the earliest forms, that started off with not even being extensions to languages, just using direct calls to the operating system to set up threads. That turns out to be very error-prone and have a lot of difficulties with ability to compose a program and use parallelism throughout the application. I think that the next thing that came along that was very promising is OpenMP. But OpenMP has its roots in high-performance computing. It was very specifically aimed at trying to accelerate the performance of loop-based code, which is very reminiscent of code that was designed to run on Cray supercomputers and other vector-oriented machines. OpenMP does a great job with that. And it can help with parallelism as well. But one thing that OpenMP doesn't offer is a high degree of composability, the ability to nest parallelism, the ability to use OpenMP blindly in one part of a program and also in another that may call each other. There can be complications using OpenMP. I think most scientific or high-performance computing users are unlikely to run into these problems as much as other developers. But this limits my ability to advocate OpenMP for everybody, this composability. I think developers who are developing in C and C++ tend to utilize modular components a lot, reuse software, bring in libraries that were developed by other groups. And what we need for that is we need a new generation of parallel programming constructs. And at Intel, we've grouped these into a family that we call Intel Parallel Building Blocks. It starts with Intel Threading Building Blocks. We continue it with Intel Silk Plus. And we have the newest member, Intel Array Building Blocks. And these three programming models each fill a different niche, but under an umbrella that we call Intel Parallel Building Blocks, where they're all self-composable and they're all composable with each other. And what this means is that you could use Silk Plus in part of your program, Array Building Blocks in another, use Threading Building Blocks in a few others, maybe libraries, mix it all together and it'll just work. It also means that you can nest the parallelism and it'll just work. It's a very fascinating technical area of why it just works versus why some models like OpenMP have problems, or if you hand thread it, you can run into a lot more difficulties. But I think the important part is that we've gotten to the place today where we can offer programming models that are not only simple to learn, but very reliable to use. And that's what we offer with Intel Parallel Building Blocks. So we continue to support OpenMP very strongly. I'm a big believer in it. I think it's a fantastic solution for what it was originally intended for. It continues to be a very important programming method for high-performance computing. And of course, it supports Fortran and C, which is great. But as we look forward to new applications, I think you'll see more and more use of the items that we have in Intel Parallel Building Blocks because of this composability. And I think that fits more with developers in C and C++ at large. So I'm very excited that Intel is able to be driving these forward in the industry and offering these different models. And I think they each have a place in our future, and look forward to feedback from all of you as you use these and give us feedback about the future directions and how to meet your needs the best.